Okay, so this is Intermediate Algebra Module 1. I'm going to demonstrate each one of these homework problems for you. So number 1 here, it just wants us to express the following rational number as a decimal. So I guess before we get going, let me show you what all the number groupings are, and then it will make this a lot more smoother. So I'm going to just draw a big box. This is the way I've learned it, and I like to also teach it this way. So just imagine this box contains all real numbers. Okay, so everything in this box will be all real numbers. And I use the pound sign to abbreviate the word numbers. It also has a symbol to denote all real numbers. It's this bold face R. So I just draw 2 lines and make an R. So all real numbers, everything in this box. Now, this box is separated into 2 groups. Okay. So this first group is called rational numbers. And then the part that doesn't interact with it, that's separate from it, is irrational. Now, rational numbers are any numbers that you can put in fraction form. Okay, so that would include whole numbers, 1, 2, 3. You can make these fractions by just putting them over 1. So 1 over 1, 2 over 1, 3 over 1. So any number that can be put in fraction form, which would be whole numbers, of course fractions. So I can say 2/3. I can say 7/10. It also includes decimals. Now there's 2 types of decimals that you can look at. It includes terminating decimals, so that means decimals that have a countable number of places, so like 0.125, or let's just say 0.62. Okay, so again, review: rational numbers, numbers that can be put in fraction form. That would be whole numbers, fractions, decimals that terminate, and then we also have decimals that go on forever, but they have a repeating pattern. So it could be like something like 0.4545 repeating. Okay, so as long as at some point it repeats, and this bar just indicates that those are the digits that repeat. So it could be like 0.183 repeating. So it'd be like 18333. It goes on forever. So rational numbers, again, are numbers that can be put in fraction form. So that would include whole numbers, fractions, of course, decimals that stop or terminate, and decimals that go on forever, but they have to repeat. So they have to have some kind of repeating pattern. Now, since we use the boldface R for rational, we cannot use that same symbol to represent, we use R for real, we can't use that R for rational. So they use a different symbol, which is this boldface Q, and I believe it is related to the mathematician that came up with studied these groups. I think he was German, a German mathematician, but it's like a boldface Q. And then we have irrational. There's no symbol for it. Irrationals are just the opposite. These numbers cannot be put in fraction form. The main characteristic of these numbers are decimals that go on forever but do not repeat. So some numbers that will go in this group are the number pi, which I know we approximate 3.14, but actually it's an infinite number. There's an exponential number e, which you can learn more about that if you do calculus, but e, we approximate that as 2.17, and then any square root that does not have a perfect square. So let's just say the square root of 3, square root of 5, any one that's not a whole number, okay, would be irrational. Okay, so all real numbers broken down into two big groups, rational and irrational. Now, inside of the rational numbers, we have subgroups, okay, so there's smaller groups that we break down. So the next smaller group contained within rational numbers, and of course all of these are real, would be the integers. All right, integers are denoted by this boldface Z. Okay. These would include negative and positive whole numbers. So negative 3, negative 2, negative 1, 0, 1, 2, 3, dot, 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 and dot, dot, dot. So, of course, all of these numbers are also rational. I can make any one of these numbers a fraction by just putting it over 1. So negative 3 over 1 would be negative 3. I can make it a fraction. It's also rational. So anything below rational is going to be rational, but just because it's an integer doesn't mean it's rational, like it doesn't translate up, because this group has decimals, but this group will not. So not everything in the group of integers will be in the group of rational, but not everything that's in the rational group will be in the integer group, but everything that is in the integer group is definitely in the rational group because it's contained in this box. Okay, I kind of said that backwards. Okay, so once again, not every rational is an integer, but every integer is rational. Okay, it's a subgroup. All right, now the next smaller group from rational would be whole numbers. Whole numbers, denoted by this boldface W. I just do two lines to kind of make my W, and then I'll do a double line, kind of like that. It's like a boldface W. Whole numbers just start with 0 and go to all the positives. So 0, 1, 2, 3, dot, dot, dot. So it's just all positive numbers, including 0. And then there's one smaller group. It is the group of natural numbers, or they might call them counting numbers. Natural numbers or counting numbers. It is denoted by this boldface N. Okay. And it just starts with the positive numbers 1, 2, 3. So whenever we count, we just normally say 1, 2, 3, so forth and so on. We don't start with 0. Now there is a group of natural numbers that you use in real life. In English, we call them Roman numerals. Roman numerals, they don't have a 0. It just starts with that letter I, or 1, and then it goes 2, 3, 4, 5. So we don't have a 0 in Roman numerals. Okay, so they just go by the counting number. So that's an actual group of natural numbers that you actually use. So this is the numbers in their groupings. And so when you see this term on number 1, and it says express the following rational number as a decimal, you know that rational numbers are numbers that can be put in fraction form, can also be expressed as a decimal. So you can use a calculator to convert this, but 2/5 is one of those common ones. It is 0.4, but I do have a on-screen calculator that I can show you. If you just do 2 divided by 5, any fraction in the calculator is going to automatically convert it to a decimal. So 0.4.